In section 8.2, I will be discussing polynomials. Remember to check out the supplemental notes posted on Canvas for more examples I don't cover in this video. Let's take a look at the first example of a polynomial, 2x cubed minus 5x squared plus 3x minus 9. The degree of the polynomial is the highest exponent. So for this example, the degree is 3. The leading coefficient is the number in front of the term with the highest exponent or the highest degree. And in this example, the leading coefficient is 2. Multiplying polynomials. When you multiply each term of one polynomial by every term of the other polynomial and then combine like terms. One possible technique of multiplying is the FOIL method. This works when you have a binomial times a binomial, or something that each has two terms. Again, FOIL represents first, outside, inside, and then last when multiplying. And last but not least for this section is the opposite of FOILing, and that is factoring. Factoring is when you write your polynomial as two items multiplying each other. So it's kind of going FOILing backwards. However, there's different techniques to factoring depending on what the polynomial looks like. So let's take a look at 3 examples. Again, take a look at the supplemental notes for more examples I don't have time to cover in this video. So first example, let's factor x squared plus 3x minus 10. This is a trinomial, a polynomial with 3 terms. And for this technique, I'm going to find two numbers that multiply to negative 10 and add to positive 3. Another way of thinking of this is two numbers that multiply to your c term but add to your b term if I were to have ax squared plus bx plus c. So, nice and easy. X and x out front. And my two numbers that multiply to negative 10 but at the same time add to positive 3, it's going to be negative 2, positive 5. Alright, let's take a look at example B. Let's factor x cubed minus 3x squared minus x plus 3. I have 4 terms. We'll learn later on in the semester some other techniques of factoring this, but for now we're going to stick with what I call the cut in half technique or the factor by grouping. GCF out of the left is x squared, and I'm left over with x minus 3. On the right, I can pull out a negative 1, and I'm left with x minus 3. Now both terms have an x minus 3 that pulls out, and my leftovers, x squared minus 1. Make sure when you factor completely. I see x squared minus 1 is difference of squares, and so that's going to factor one more time to x minus 1 times x plus 1, and now my problem is completely factored. One last example. Let's take a look at 6x squared plus 17x plus 7. This time I have a number out front, and so I can't just do two numbers that multiply to 7 and add to 17. That doesn't work. So when I have a number out front, one technique I can do to factor is use what I call the a times c method. So we start by multiplying the a and the c term. So a times c in this case is 6 times 7, which is 42. And now close to the other technique, this time I'm going to look for two numbers that multiply to 42, but at the same time add to 17. And so we get 3 and 14, both positive. Then I'm going to rewrite my trinomial into 4 terms. The first term and the last term stay, but I'm going to replace my middle term with my two new numbers and put an x next to it. So plus 3x plus 14x. And now that I have 4 terms, I'm going to factor by grouping or use the cut in half technique. GCF out of the left is 3x. I'm left over with 2x plus 1. GCF out of the right is a positive 7. I'm left with 2x plus 1. Both have a 2x plus 1, so that pulls out. And I'm left over with 3x plus 7. And now my polynomial is completely factored.